Okay, so hey guys, let's solve the problem 11840 Stone Game 2. Okay, so what this question is saying is bit confusing in starting if you read this sentence or the explanation. Let me just give you a brief introduction what this question is. Okay, so let me copy this and visualize what this question is saying. Okay, so in this, I have given an array, okay, known as files. And there is a M. Okay, let me use like there is a M which is initialized as 1. Okay, so basically in index 0, I have 2 stones. In index 1, I have total number of 7 stones, like counting like this. And in 9, in there I have 9, then 4, and then okay. So there are some stones at index 0, 1, 2, 3, and 4. Okay, so here are 2 stones. Okay, 7, 9, 4, and 4. Okay, visualize. Okay, now there are 2 people just playing the game: A, Alice, and B, Bob. Okay, so I'm going to visualize Alice as green and Bob as red. Okay, so when starting from the game, always Alice will play first. Okay, and the M is initialized as 1. Now what this M is used for. Okay, so what this game is all about is, if I have a turn, suppose I'm a person, okay, and it is my turn. What I will do is, I'll see what is the value of M. Okay, suppose I'm standing at this index. Okay, now suppose I'm standing at index 1. Okay, and it's my turn. And I'll see what is the M. So suppose if M is 1, so I can go from the I index till I plus 2 into M. Okay, so means I can go from index 1 till 1 to 2, 2 plus 1, 3. Okay, so means I have this much of range. Okay, so either I can choose go for this or go for this, not this one. Okay, so I can go from 1 till I can either choose 1 or 2, excluding 3, like this. Like, you know how this bracket works? Means including 1, excluding 3. Okay, so now let's visualize what this game is saying. Okay, so let's remove this all. Okay, so it's Alice time. So let's go for the Alice. Okay, now Alice. Now it will see M and it will see the I. So I is here. Okay, so Alice see that he can go from 0 till. Okay, so in this range he can choose any number of piles. Means he can choose only this index of all piles, means all stone of this index, or he can go for all stone of this range. He have 2 options. Okay, so option 1 and option 2. Okay, now if I choose any index, any range, I have to change the M. And what this M would be equals to max of the previous M and the range I took. Suppose if I took 2, so it would be 1, comma 2. What is the max? 2. So M would change to 2. Okay. Now it's time for L. Bob. So I is here. So Bob can choose 2 into 4. So he can go from this index to the out of index. So he can choose at max all these students. And this is the game. This is all the game. Now, what you have to do is maximize the ALS scores. If Alice would have choose 2 index, he would only have 7 plus 2. But the moment if it's 9 plus 4 plus 4, 8, 8, 6, 17, Bob would have 17 stones, which is not right. So what Alice would do optimally will, he would go for this one. Okay. So in the start deck, you would only have 2. Okay. Now, Bob will choose, so he'll choose this much amount of stones max, because Bob is also want to play in a optimal way. So 7 plus 9. Now, what Alice will do is take all this. It will do 4 plus 4, 8. 8 plus 10. It is max. And the previous one, it was only 8. Okay, so answer is 10. We don't have to make Alice win. This is not the question. We have to maximize the score of the Alice. Okay. So how this question is solved? How this question will solve is remove the extra. That's yeah. Now that's good. Hey, don't go quickly. Have to make security again. Okay. Now that's good. Now in Alice, if I have to was Alice, I can either go for 0 only 0 index, or I can go from 0 till 1 index. Okay. Now visualize this. If I have 0, then Bob can only choose from 1 or 2, well, only these values. Okay. So he will always go for maximum value. So he will choose this much amount. So Alice would now be at index this. So he can choose either 3 or 3 comma. If Bob was at 2, Alice was at 2 index, so he can choose all this. So Alice's chance would be n. So it is out of index, so there is no chance. So this is the recursion. Unless Alice wants to maximize and Bob want to minimize. Now what this question? What this is? Now, suppose if I am Alice and you are Bob. Okay. Now it's my turn. So I want key in the end of the whole game. I want me to have the maximum stones. Okay. And with respect to you, you want to minimize my number of stones. Just think of my perspective. Okay. If I'm talking about me only, I want to maximize my stones. And on the opposite hand, you want to minimize my number of stones. Okay. Now suppose there is a filter. Okay. Suppose something like this. And you Bob. And there are some choices. Okay. Okay, so I have 1 choice, 2 choice, 3 choice, and 4 choice. Okay, there are some 4 steps, and you can take any of the steps. Okay, so which step would you choose? The one The one which will maximize my number of stones, or the one which will minimize my stones? Means suppose it have a value 1, 2, 3, suppose 1, 8, 10, and 12. 2, 12. Okay. Now, these are some choices. If I will choose this step, Alice would only go for 1 stone. If I choose for this step, Alice can have 8 stones. If I choose this step, Alice can have only 10 stones. And if I choose this step, I can have 12 stones. So which step would you choose? This one or this one? Of course, you choose this one as it is making my number of stones only 1. So you want to minimize my number of stones, but on respective of me, I want to maximize my stones. Is it? Now, this is the main concept. We are playing on the behalf of Alice. So I want to maximize my stones. And when it's your turn, you have to find a well step that will minimize my count of stones. So while coding, I'll teach you what I'm saying is. If you didn't understand, tell out. Okay. So let's find the length of the. Let's change this to nums. Okay. So length of nums. Now I need a DFS. So I can choose 1 stone or 2 stone or any number of them. Okay. So in this, I need my index, on which index I am currently, and Alice or Bob, whose turn is this? Is it of Alice turns? If it is of Alice turn, this would be 1, or else it would be Bob, 0 if for Bob, and M. Okay. Okay. Now, if index is out of range, then it's return 0. Okay. This is the base condition. Now let's call the DFS. 0 is true, since I have to play from the Alice side first, and M is 1. Okay, here you can see M is says as 1. Okay, this is the thing, and let's return this. Okay, understood till this? A base condition, a call of the function, and this. Now, the main. Okay, so I want to, like, suppose if my index is this and my M is, I can choose from all this, either I can choose 2 or 2 or 7 or 2 or 9. So I need a for loop. So for k in range 0 to 2 into M. Okay, so 2 into M. So this is my only range. I can choose anything between 0 to M, okay, to a correct index. So now, if I want to make a sum, like if I'm standing here and I want to make a sum and keep on doing the sum, I would rather have a prefix sum. Or I can just, for now, just keep it aside and let me just. So total stones I have. So stones would be sum of nums I till I plus k plus 1. Okay, so means if I'm standing at 0 index, so 0 till where I'm wanted. So I need a sum of this or this or this. Okay, so I need to find a sum. Now, if AB equals to true or else, if else turn is this or box turn. Now, if it is of else turn, so if it is of else turn, I want maximum value. So float minus infinity if AB and float. So rest equals to max of. I need a step that maximize my stones. So it would be D stones plus DFS, and what's the next? It would be I plus A plus 1 not not AB false, then max of M comma P plus 1, else it is of if it is of Bob's web. Bob's, so it would be minimum of rest comma save DFS. Okay, yeah, that's all. And what else I need? Yeah, that's all. And let's run this. K is not defined. Okay, why is it scattered? None by and yes, I have written something out of this. Address. Yeah, it's moving perfectly. Now, how can we remove this? In this, we are for every for loop, we are summing from I to I plus 1. So instead of this, I can have a tone and the starting it would be 0 and plus num I plus 1 plus k. Yeah. Okay, so there could be a chance of out of if I plus k is greater than equal to n, right? There will be chances like whoever is out of range, like I said, like there will be a chance of this. Okay, so yeah, it is moving perfectly, but this will give a DLE because we are using a repeated recursion. Let's see. Because in this we are keep on going forward. Like this gives us a DLE which is expected. So now the term K comes is DP, dynamic programming, which everyone scares of. Okay, so how can we apply DP out of it? I think we just what is D? It is just a memorization. Like if we have calculated a value for a particular set of values, if I calculated this, then why have to calculate it again? I can instead of just use the value. So if I comma AB comma M in DP return DP. Simple. And I have to press. Perfect. Now this becomes a DP. Don't you find it easy for now? Like the main part is of recursion. How we can move this into DP? Just store the calculated part. It's giving really good thing. Yeah. It is n squared is this is giving a really nice complexity. N squared, y squared. But now you will say why n squared? Thing is we are using three variables here. Now see, I can move from 0 to n. So m can go from 0 to n. If it goes beyond the n, we are still use it for n because we will break this. There. Now AB. Now as tell you. We have three variables I, A, B, M. Now you will say it should be 3n square. But no, I would go from 0 to n. A can go from max till like true, either true or would be false. So M can go to 2n, but we are only using till n because we will break here. So it would be n into 2 into n. So it would be n square. Eventually, it would be n square. Is the time complexity. Right? N space, n square. And hope you understand this concept. It is a bit tricky at the starting if you read from this explanation. And hope you understand this concept. And if you do, just give it a like and share with your friends. And bye bye.